Hello, my name is Muhammad Nikyani and my metric number is BS17110002, and this is my answer for question number 3. So this is the question, and this is the data given, and this is the research question given. With this research question, there is a problem where there is lack of keywords, which is for the relation and the population. So based on this data, we can make a new research question, which is based on both of the variable, which is weight and food intake. So this is our new research question. Is there a statistical significant relationship between food intake and body weight among UMS male students? Moving on to the experimental design. So our experiment will based on one population, which is UMS male student, and we will take one sample from this population, and the sample size is 10. The body weight and food intake in gram and kilogram will be taken from each student, and the data is a scale type. So we will organize our data in table as shown, and also we need to do the statistical analysis, which is the assumption test first. So we need to first set our working directory, get our data, and we can do a box plot to present the data. So for the first variable, which is the weight, we can do this, and also this for the food intake. So as we can see from both box plot, the data can be seen is normally distributed, but we need to do the assumption test first. So we do the Shapiro test for both variable. So as we can see, both of the variable is normally distributed because the p-value is greater than 0.05. So next is we need to do the Levene test for homogeneity of variance. First, we need to install the package, which is CAR. In my case, I already installed it. So we load the CAR package using library, and we can run the Levene test. So as we can see from this test, the p-value is smaller than 0.05, which means the variance of both data is not equal. So we cannot do a correlation test, Pearson correlation test or regression test for this kind of data, because it's violate the assumptions for those parametric tests. So what we can do is a Spearman's correlation test. So for Spearman correlation test, the hypothesis is there is no association between food intake and body weight among UMS male students. And the alternative hypothesis is there is an association between food intake and body weight among UMS male students. So the criteria for this test is alpha at 0.05. It's a two-tailed test, and the degree of freedom is 8. So first, I want to plot my data in a scatter plot, I will be using a ggplot. So first we need to install the package. but I already installed it, so we load the package and we use this script to do the plot. So this is the scatter plot for the variable. As we can see, there is like no correlation between the variable. And moving on to our Spearman correlation test, we will be using this script and we can run. So from this test, there is the p-value of this test is 0.27, which is larger than 0.05. So we cannot reject the null hypothesis, which is there is no association between food intake and body weight among UMS male students. But I also need to report the R correlation coefficient, which is negative 0.384, which is considered a poor negative correlation between the variable. So, as a conclusion, there is no association between food intake and body weight among UMS male students. Thank you.